Okay, so we're going to start recording from here. So let's look at an example like this. Suppose we want to divide the polynomial 6ax third minus 19x squared plus 19x minus 2. We want to divide this by 2x minus 3. So obviously now what we have is a polynomial, actually something with 4 terms, divided by a binomial. And this has to be done with the operation that we call long division. What we have to make sure is that all the terms are in what we call descending order. The highest power first, then the next highest power, and then the next highest power. The n should be just a plain number. When you have that set up, and we do here, they very nicely put it in that order, we write it like a standard long division by putting the divisor, the 2x minus 3 on the outside, and inside our division sign is this long polynomial, the dividend. We are looking for what's called the quotient. The result or the answer to a division problem is the quotient. And we're going to get the quotient using what's called the quotient and remainder. And if you recall, what we said to do is, because it's very hard to divide by the whole binomial, just work with the first term, the 2x. Divide the 2x into the 6x cubed. Actually, all we're doing is trying to get a guess as to what we should put on top. Well, that's not so hard to do, because when I divide the 2 into the 6, that'll give me 3. And when I divide the x into the x cubed, remember now we're just, when we're dividing the variables, we subtract the exponent. So this is an exponent of 3, this is an exponent of 2, so I get 3x squared. Where you put the answer on top doesn't matter. It's not like regular division of numbers that you have to be very careful as to where you place things. Any place on top works. Okay, now if you remember what we said the steps were. The steps were first to divide, which we just did. I'm going to put the steps over here. The first step is to do the division. The second step is to multiply. Just putting a dot there. We take what we put on top and we multiply the whole binomial by it. So we take the 3x squared and multiply by 2x, and that gives us 6x to the third. And I also take the 3x squared and multiply it by the negative 3, which gives me negative 9x squared. So even though we only divide by the first term, when it comes to the multiplication, we have to actually multiply by everything that's there. The third step we do is subtract. We subtract what we just put down from what was originally there. And since this is polynomials, the easiest way to do the subtraction is to change the signs of each term and then just combine. So this 6x cubed was originally positive, so it's becoming negative. And this 9x squared was originally negative, so it is becoming positive. So we change our signs so we can divide. And now we do negative 6x cubed with a 6x cubed with negative 6x cubed cancel out. And negative 19x squared and positive 9x squared. Well, negative 19 plus 9 gives us negative 10. And just bring down the x squared. So we did the subtraction. The last step is to bring down the next term. So we're going to now bring down the next term, which is positive 19x. And we go right to the back to the start of where we started and do the whole set of steps all over again. Now on this new negative 10x squared plus 19x. So again, I take the first term, the 2x, and divide it into the negative 10x squared. So the 2 into the negative 10 gives me negative 5. And when I divide x into x squared, remember I'm subtracting the exponents. I'm getting an exponent of 1, which is just x to the 1 or plain x. I now take what I have just put there, including the sign, the negative 5x, and multiply it by the 2x minus 3. So I have negative 5x times 2x is negative 10x squared. And negative 5x times negative 3 is positive 15x. Okay, once I've done the multiplication, I'm up to doing the subtraction. And again, I'm going to change my signs so that the subtraction is easier to do. So then I'm left off with a negative 10x and a plus 10x squared, a negative 10x squared and a positive 10x squared, which cancels out. And the second term, I have a positive 19x minus 15x. 19 minus 15 is 4. I get 4x. And now I bring down the next term, which is negative 2. And start the process again. It's long, it takes a while. I take the 2x and I divide it into the 4x. Remember, the division is just first term into first term. So 2 into x gives me 2. 2 into 4 gives me 2, and the x's cancel out. Remember, they both have exponents of 1, so when you subtract it, you get 0. That's just a plain number. There's no x's left. It's just 2 into 4 gives me positive 2. And I take that answer that I just put on top and I multiply by it. 2 times 2x is 4x. 2 times negative 3 is negative 6. And now I'm ready to subtract, so I'm again changing my sign. This is a positive 4x, will become a negative 4x. This is a negative 6, it will become a positive 6. Again, the 4x and the negative 4x cancel, and then I have negative 2 plus 6, which gives me 4. And there's nothing more to take down. There's nothing, no further steps. We can't go back. There's nothing to bring down. So what we're left with is our remainder. And depending on how the question is worded, sometimes they ask you, give the quotient and the remainder. The quotient, it would be the 3x squared minus 5x plus 2. The remainder is 4. I've even seen questions where all they're asking you, what is the remainder? Well, you have to do all the work so you can figure out that the remainder is 4, but the remainder is 4. Another way of writing the answer, the quotient, is just to write the 3x squared minus 5x plus 2 plus the remainder 4 over the divisor. This is a very good way of writing the answer as well. Quotient, which is what's on top, plus remainder over divisor. And that is your answer for dividing polynomials. Now notice, you have to do this long division. Remember, what's extremely important is to make sure that you have it set up properly in the beginning. I'm going to do one more example with you, and then I'm going to give you one to try. Okay, so let's try this one. There, try this example. Can I erase this now? Everybody okay with this? Okay, the problem is this. We have 6y to the third minus 8y plus 5 divided by 2y minus 4. And again, we want it, they're asking us to divide it. It's not just a matter of reducing a fraction. It is a division problem. And since both my numerator and my denominator are polynomials, this is a trinomial, this is a binomial, we have to use the long division. So let's set up our long division. On the outside, we put the 2y minus 4. On the inside, we have to put the 6y cubed minus 8y plus 5. But wait a second. Remember, I told you everything has to be arranged in descending order. Sometimes the terms are just out of order. They're not the way they're supposed to be. These terms are in descending order. I have the highest exponent, then the next, then the plain number. Except something looks funny. I have a 6y cubed. That's my highest power. That certainly goes first. But the next thing I expect to see is a y squared term. If I'm in descending order and I start at y cubed, then I should go down y3, y2, y number. And there's no y squared term. Now, usually that doesn't make a difference, and you just go along with the problem, except when you have this long division. You have to account for every term. So if a term is missing, in this case, the y squared term is missing, you have to put in a filler for it. Well, we don't have any y squared, so I'm going to put in plus 0y squared. It's like a space maintainer. I need the space for the y squareds. And there is none here, so I put it in by just putting a 0. I can't just put in a plus y squared, because a plus y squared would be 1y squared. And we don't have any y squareds. That's why I'm putting in 0y squared. Of course, then I continue with my negative 8y and my plus 5. Okay. And now we're going to proceed the way we did before. We're going to take our first term and divide it into our first term. 2 into 6 goes 3. Y into y squared, again, subtracting y cubed, subtracting exponents gives me y squared. I take what I put on top, the 3y squared, and multiply it by my whole binomial. 3y squared times 2y is 6y to the third. Remember, when you're multiplying, you're adding the exponents. And 3y squared times negative 4 is negative 12y squared. And now we can see why it was so important to put in that 0y squared, because otherwise I would have had this y squared term and I wouldn't have any place to put it. That's why I say it's a place maintainer. Okay, now we're going to subtract. So this is going to become negative, and this is going to become positive. So now we have 6y cubed and negative 6y cubed, so that cancels. And here we have 0y squared plus 12y squared, which gives us 12y squared. And we bring our next term down, which is negative 8y, and start again. 2y into 12y squared. So the 2 into the 12 gives me 6. The y into the y squared gives me y. I put a 6y on top. And I multiply everything by what I just put on top, the 6y, 6y times 2y is 12y squared. 6y times negative 4 is negative 24y. And I have to subtract, so again, here am I changing my signs. This is a positive 12y squared, so it will become negative. This is a negative 24y, so it will become a positive 24y. And 12y squared and negative 12y squared cancel. And now I have negative 8y with positive 24y, which gives us positive 16y. And I bring down my next term, which is the plus 5. Notice, you have to be neat on this because otherwise you're going to get mixed up as to what you have to bring down next. And again, 2y into 16y, well, the 2 into the 16 gives me 8, and the y's cancel out. So I have to take the 8 and multiply by 2y, which will give me 16y. And the 8 times the negative 4, which will give me negative 32. And again, I'm going to change the signs. This is going to become a negative. This is going to become a positive. And I have 16y minus 16y, which cancels. And now I have 5 plus 32, which gives me 37. So that's my remainder. Again, I write this plus 37 over 2y minus 4. And this is my answer. And that's how we do these problems. Again, as long as you've got your initial setup done properly, you're okay. Make sure you're in descending order. I'm going to give you one to try now while I take attendance. Okay, so I'd like you to try this example. Again, it's a division. So I want you to divide 4x to the third minus 11 minus 60 by the polynomial 2x minus 4. Okay, I'm going to give you time to do that while I take attendance. Jesus and Antonio. Avila, Jackson Avila. Hi, Jackson. Tiffany. Tiffany here. Kayla. Kayla Brantley.
Here.
Hi.
Good morning.
Good morning. Tashana Caesar. Tashana. Dion Carter. Dion. Wensley Charlemagne. Wensley. Tatiana Collins. Hi, Tatiana. Thanks. Awa Diallo. Good morning. Let me just mention that I do not penalize people if they don't have perfect attendance. But when it comes to my final grades, and some people just need a little bit of a boost. Their average is 78, which is really a C, and I'd like to give them a B. If their attendance has been good and all their homework is done and everything else was done properly, then I will probably just up them. As I said, I don't penalize not coming to class, but it can affect your mark. Ashay Douglas. Ashay. Ilana Estee. Eliana, I'm sorry, Eliana. Emily Gomez. Anastasia Guerra. I'm not doing too well today. Zenabu. Zenabu here. Ismail.
Here.
Hi. I knew you would be here. That's why
I just had trouble unmuting.
Yeah, okay. You see, some people I wait longer for than others because I think they're here and they just haven't been able to answer. Jaden Jackson. Jaden. Ashiana Jacobs. Ashiana. Okay, good morning. Anijah John. Anijah. Thomas John.
I'm here.
Hi, good morning.
Order.
Paul LeBrun. Ashley.
Oh, sorry, here.
Oh, hi. Okay, got you. Have a good day. Is Ashley here? Angelica, I know you're here. First thing. Tayan Regist. Hi, Tayan. Akeem.
Here.
Hi, good morning. Craig Craig Ricketts. Giovanni Rowe.
I'm here, Professor.
Hi, Giovanni. Oh, yeah, you have a great record. I'm sorry. Devonly St. Jude.
Yeah.
Did you see the text I sent you? The chat?
No.
Can you look at the chat and see there? I sent you one directly to you. Do you see it now?
Yeah.
Okay, can you send me an answer? And that, obviously that's affecting your mark, and I know you don't want that to be. So somehow email me when you're available and I'll set it up for you.
All right.
Is that okay?
Yeah.
Okay. And Najay Waddell. Okay. Guess we got that. Okay. I hope everybody saw their emails where I sent you your marks up to right after the midterm. I like to give people an idea as to where they stand halfway through the term. Obviously, that's not your final grade. There's no mid-final there. There's going to be other tests. There's going to be other homework. This just gives you an idea of your standing at this point. If your marks are not what you would like it to be, if you think it should be higher or you want it to be higher, one of the reasons your mark might not be as high as it is because you're behind either on the homeworks or you're missing tests. Make sure you make up anything that you're missing. If you don't find it because it's past the due date, just email it to me at a date when you can take it, and I will open up the test for you. There is no such thing as not being able to take a test because the time passed. There might be somewhat of a penalty. You might not get 100% of the points. You might just get 90%, but you will get credit. So don't leave something because you don't see it. At this point, there has been a total of 3 tests in this term. There has been one on Delta Math, a regular test on Blackboard, and the midterm on Blackboard. So 1 test on Delta Math, 2 tests on Blackboard. You should have taken all 3 of those tests. Now, if you missed the test 1 on Blackboard and you just took the midterm, I'll count your midterm mark as that test, but there is a bit of a penalty because you've not done all the work for the term. If you got a bad mark on that and you did better on the midterm, then I'll just use I didn't do it now, but when it comes to the final grade, I will use as that mark, your midterm mark, so it'll up that grade. But you must take that test. You must have done all the assignments. There are also, I think we're up to number 12 homework on Delta Math. Again, by the end of the term, there'll be something like 21 or 22 of these homeworks, and it's worth about 10% of your final grade. Remember, 35% of your grade is your final exam, 25% of your grade is your midterm, so that's 60% of your grade. But 40% of your grade is your homeworks, the class tests, and your participating. Again, I basically consider the class tests and the homeworks as for your final 40%. So I will probably use like 15% will be just the homeworks alone, and 25% will be the other tests and things that we've done during the term. So we really have to be aware. And as you see, I do take attendance, so I know who's joining us and who's not. Some people can't join because they have other commitments at that time. I mean, if you miss a class or two, well, you can always review it on the recording. But you really should be part of the class and doing the work with the class to get your complete participation mark. Okay. Is there anybody who has not completed this example? Okay, so let's do this together. And then we'll continue with something else afterwards. This is basically the end of chapter 5. When we're going to be starting chapter 6 today. When we complete chapter 6, there's going to be a test on chapters 5 and 6. Okay, well, thank you so much for your answer. Let's see if that's what I get as well. So I have to rearrange these terms. I have 4x squared minus 11 minus 6x. And I need my terms in descending order. So my first term is going to be 4x squared. My second term is going to be the negative 6x. And the last term is going to be the 11, the minus 11. And I'm going to put the 2x minus 4 outside. Again, I have to do this as a long division because I have a polynomial divided by a polynomial. So I divide the 2x into the 4x squared. Remember, first term into first term. So 2 into 4 gives me 2. X into x squared is x. Now we take the 2x and multiply by the 2x minus 4. So that gives me 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Okay, remember, whatever I put on top, I have to multiply by everything. And now I change my sign so I can subtract. So this is going to become a negative 4x squared. And this is going to become a positive 8x. And now we do 4x squared minus 4x squared. That cancels. Negative 6x plus 8x gives me positive 2x minus 11. I bring down the next term. And I start the division again. 2x into 2x. So the 2 cancels into the 2. And the x cancels into the x. So what I put on top is a 1. Don't forget, you're canceling out with division, so you're getting a 1 there. And now we have to, again, multiply. So now we multiply 1 times 2x, which gives me 2x. And 1 times negative 4, which gives me negative 4. And now I'm up to subtracting, so I'm going to make this negative and this positive. The 2x and the negative 2x cancel. Negative 11 plus 4 gives me negative 7. That's my remainder. So my final answer I write as 2x plus 1 minus 7 over 2x minus 4. If you had written plus a negative 7x over 2x minus 4, that would also have been correct. And that's how you do it. Again, make sure that you have your terms in descending order And if there's anything missing, in this case, there was nothing missing, we started with an x squared, then we had an x, and we had a number. But if any term is missing, then you have to put in a 0 for it as a base maintainer. Okay, so this takes care of chapter 5, which was a chapter on working with rational expressions, fractions, algebraic fractions, and also division of polynomials. So now we're going on to chapter 6. And what we're going to be studying in chapter 6 is something called radicals. So I'm going to erase this, and we're going to start with our discussion of something called radicals. This symbol that looks very similar to a division sign, except that instead of having like a curve here, it looks like the front is a check mark, is what's called a radical sign. And that radical sign is used to indicate what is called a root of a number. For example, if I write radical 25, what I'm asking you to find is the square root of 25. And the square root of a number is the number that when you multiply it by itself will give you 25. Now, if you think about it, there actually are two numbers that work. There's a positive 5, because positive 5 times positive 5 is positive 25. And negative 5 times negative 5 also gives you 25. But when we talk about the square root of a number, and we use this radical sign, we always call, this is what's called the principal square root, which really means the positive one. In other words, this is equal to 5. This is what we're going to, so what we're going to be talking about are square roots of numbers. This radical sign actually is not used only in square roots. You might see something like this. You might see a radical sign with a little number inside the check mark. This is read the third root or cube root of 8. And what we're looking for in that case is the number that you multiply 3 times to get 8. And I think everybody realizes it's going to be 2, because 2 times 2 is 4, and 4 times 2 is 8. The cube root of 8 is 2. Notice when there is no number written in the check mark, it's understood to be a square root, just a plain square root. This number is actually called the index of the root. Here the index is 3. Here, when no index is written in, it's understood to be 2. You're looking for 2 numbers that multiply to 25. Here you're looking for 3 numbers that, well, actually a number 3 times that'll give you 8. We can even use this like something like this. This is read the 5th root of negative 32, which means I'm looking for a number that when I multiply it 5 times is going to give me negative 32. And that number happens to be 2 as well, negative 2 as well, because negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 gives us our negative 32. And what's interesting is that when I have an index that's odd, I can have a negative sign inside my radical. Because if you multiply a negative number, an odd number of times, your answer is going to be negative. But when you have an even index, this is an even index because its index is 2, you cannot have a negative number inside your radical, not to get what we call a real answer. In other words, I can't do something like the square root of negative 16. Well, not at the beginning of the chapter. We're going to talk about doing something with it at the end of the chapter, but in real numbers, in the numbers that we use on a daily basis, we can't do the square root of negative 16. Why not? Because it can't be positive 4, because positive 4 times positive 4 is positive 16. It can't be negative 4 because negative 4 times negative 4 is also positive 16. Hold on a second. There. Okay, I'm in the middle of teaching. Hey, you want to ask me something? Okay, I'll call you in between classes. Oh, it should be in that because of now. Okay. Okay, so when we're dealing in this chapter, even though we can deal with any kind of index, we're mostly going to be concerned with square roots. And that means the index is even. So the numbers inside our square roots have to be positive number in order to get real answers. This is what we call not real. It's not a real number. It's not a number that we use on a daily basis. There are numbers that are called imaginary numbers, but those are, we have to say right at the beginning that what we're going to be doing is dealing with these imaginary numbers. Sorry, excuse me. Hi, how are you? I can't talk now because I'm teaching on Zoom. Okay. I'll call you back. So, one thing we've learned so far is the meaning of this radical sign. We're going to see an alternate, I'm going to do that towards the end of the chapter. There's an alternate way of writing this, and this is something that you really have to learn how to use your calculators with, because most of these square roots, unless they're nice, perfect squares like 25, a number that we know is 5 times 5, in order to find the square root of the number, we are going to need a calculator. So if you haven't used a calculator until now, it is of utmost importance that you get your calculator and start working with it now. Now, again, when we use the radical sign, we always mean the what's called the principal square root, which is always a positive number, not the negative number. And when we have a square root of the negative number, unless we're told to put it in this special, what we call imaginary form, it's really not, we can't do it, it's not a real number. So the question is, how do we find square roots? Well, I would assume that a lot of the numbers that are perfect squares, you know the square roots of. For example, if I ask you what is the square root of 81, I would venture to say most people would know the answer is 9, because 9 times 9 gives you 81. I don't know if everybody knows that the square root of 225 is 15. But if you don't know that, you can always check it on your calculator. Your calculator should have a square root button. My calculator happens to be, and this is typical of TIs, that you have to press the second, and then you press the X square button and put in the 225, and your answer will come out to be 15. If you have a problem using your calculator, you should send me a picture of your calculator, and I will tell you which buttons to press in order to find the square root. Now, there are cube root buttons, etc. as well, but as I said, the cube root, the third root, is not so frequent, and it'll only be simple numbers. You should be able to do that without a problem. So the question is, how do we know how, so we have these numbers that we know how to take the square root of. And what do we do with the variables? How do we deal with variables? So the rule is basically that when you have a variable inside your radical, for example, if you have the square root of x to the 6th, what you do is you take your exponent and divide it by the index. Remember, the index is supposed to be this number that's in this check box, but there's no number here, so it's understood to be 2. So I do 6 divided by 2, and I get x to the 3. And notice it makes sense, because if you multiply x to the 3 by x to the 3, what you're going to get is x to the 6th. So what happens if I have something like this? Suppose I have a number like this. I want to find the square root of 50. Now, I can't think of any number that when I multiply it by itself will give me 50. I know that 7 times 7 is 49, so that's a little bit too small, but 8 times 8 is already 64. So obviously 50 is not a perfect square. So what do we do when we have a number in a radical that's not a perfect square? So there are two options. Option number one is just to go to my calculator. And if I put in my calculator the square root of 50, I get a number that looks like this. 7.071067812. And it stops there, but the only reason it stops there is because there's no more room on my calculator to put more digits. if you notice, this is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 digits. My calculator, some calculators have room for more digits. My calculator has room for 10 digits. Some have only room for 8 digits. Whatever it is, this really is not the exact answer. This keeps going on and on. If I had a calculator that had room for 100 digits, it would fill out all 100 digits. And not only that, there would be no pattern. Like if you have a fraction like 1/3, then you get 0.333333, and it keeps going on and on, but at least you see a pattern. Here, there's no pattern. This is what's called an irrational number. Any number that is not a perfect square, not a number times itself, like a number like 25 or 64 or 81, those are perfect squares. If it's not a perfect square, then when you take its square root, you get an irrational number. You get a non-ending, non-repeating decimal. It never ends, and it doesn't have any repeating numbers, and it keeps going 2, 3, 2, 3, 2, 3 afterwards. It's non-ending and non-repeating in its decimal form. So the only thing we can do with that is nobody wants to use these long numbers, so sometimes what we do is we round off. So I might say, oh, the square root of 50 is 7.07. Now, obviously, that's not an exact answer, but it's a close enough answer for most people's purposes. But if we want to keep things exact, there's another thing we can do. We can do something that's called simplifying the radical. Now, the way we simplify a radical is instead of going to our calculator, is we take the original number that's inside the radical and try to break it up into two numbers that multiply. We're looking for two numbers that multiply to, in this case, 50. That when and one of those numbers has to be a perfect square. Well, I think everybody realizes that 50 could actually be written as 25 times 2. Again, make sure when you're trying to do the simplification, you pick the two numbers that multiply to the number inside the radical, and one of those numbers has to be a perfect square. And if you have a choice of numbers, then pick the biggest number that has a perfect square. And break up your square root of 50 into the square root of 25 times the square root of 2. 25 times 2 is 50. We'll break this square root of 50 into the square root of 25 and the square root of 2. Notice I put the perfect square number first. I now can take the square root of 25 and I get 5. And inside my radical, I get 2. This is read 5 times radical 2, or just 5 radical 2, or 5 square root of 2. But basically, it's called simplifying because the number that's left inside the radical, which is a more complicated number to deal with, is a smaller number. If you put this in your calculator this way, or you put it in this way, you put in 5 and then put in a radical 2 next to it, you'll get the exact same decimal value. This is what's called simplifying the radical. Now, when it comes to variables, suppose I have something like this, x5. Remember, when it came to the variables, what I said to do with the variable is to take the exponent and divide it by the index. Well, in this case, my exponent is 5 and the index is 2. Remember, when no index is written in, it's understood to be 2. And 5 divided by 2 is either 5 halves, which is a fraction, or if you change it and you put it in your calculator, get 2.5. We really don't, when we're trying to work with these radicals, want to get fractional or decimal exponents. Yes, your calculator can handle it. If you put in your calculator 17 and then put in the exponent 2.5, it'll do something for you. It'll give you an answer. But in terms of simplification, we don't want to be left with decimal exponents or fractional exponents. So what we do in that case is, just like we broke up the 50 into two numbers that multiplied to 50, we're going to take that x to the fifth and break it up into two parts. Now, this is not an even number, so it can't be divided by 2 evenly. So what we do is we take 1 away from this number, which gives me 4, and I break the x to the fifth into x fourth and times x. Just like we broke the 50 into 25 and 2, the x fifth we can break up into x fourth and x1. Now remember, to be a perfect square for the variable, all you need is your exponent to be even, needs to be able to be divided by 2. Now I can take that exponent, the 4 divided by the 2, that gives me x squared, and this gives me x squared radical x. So now we know what we can do to simplify radicals. The numbers we break up into one being a perfect square and whatever is left over. The variables, if it's got an even exponent, it's already a perfect square. If it doesn't have an even exponent, take 1 away from that exponent and use that exponent. So let's say I gave you an example like this. I want to simplify radical 48 x fourth y seventh. I want to simplify this as much as I can. So again, when I'm simplifying, I'm breaking up into two radicals. The first radical will contain all the perfect squares so that eventually I can take them out of the radicals like I did here. I'll put a 25, I'll put whatever it is so I can take its square root. In the second radical, I'll put everything that's left over. Okay, so now we look at the 48. What number can we break 48 into? Well, if you think about it, 48 is 16 times 3. And 16 is a perfect square. Now, somebody might have said 4 and 12, but between 4 and 12 is 16, which is also 48. Sometimes you have a couple of choices. When you have a couple of choices, you want to pick the choice that gives you the largest perfect square. 16 is bigger than 4. I'm going to change this to 16 and 3. Okay, that's the harder part, is dealing with the coefficients. When it comes to the variables, the first thing I see is an x to the fourth. Now, x to the fourth is a perfect square because its exponent is even. So I don't have to do anything. I don't have to split that up. I just put the x to the fourth in that first radical. And then I go to the y to the seventh. Now, y to the seventh, if I divide that by 2, is going to give me a fraction or a decimal. I don't want that. So I take 1 away from the 7. That gives me y to the 6th. And that leaves me y for my second radical. Remember, 7 plus 1 will give 6 plus 1 will give me the 7. So in this first radical, I have all the perfect squares. In the second radical, I have what's left over. And now the final step is to take the square root of this perfect square. So the square root of 16 is 4. Remember, with the exponents, I'm just dividing them by 2. So 4 divided by 2 is 2, so that gives me x squared. And 6 divided by 2 is 3, so this is y to the third. And this gives me times radical 3y. And this is what's called simplifying that radical. Now you're going to say, oh, it looks so simple to me, but that's, remember, these are technical terms and that's what they want. We want to get left with as small an item inside the radical as possible. Okay, let me give you one to try. Okay, so let's say you have this one. Suppose I want you to simplify 18, the square root of 18 x fifth. Give you a minute to try that. Okay, let's see what we can do with this. And again, 18 is not a perfect square, so I'm going to simplify this by breaking it up into 2 parts. The numbers that I think of with 18, and this is something you can always try, especially on your, I think most people would know it in their head, but if not, just try dividing your number either by 2 or 3 or 5, those type of numbers, and seeing if the other number you get is a perfect square. Notice when I divide 18 by 2, I get 9, and that is a perfect square, so I'm going to put 9 in the first radical and 2 in the second radical. The x fifth, that's easy to break up. It's odd, so I subtract 1 from it. 5 minus 1 is 4, so I'm getting x to the 4th here and x here. And then now I can take the square root of 9x to the 4th. The square root of 9 is 3, and 4 divided by 2 is 2, so it's 3x squared radical 2x. That should have been the answer you got. Now, why is it so important to know how to simplify radicals? Well, it has to do with the rules for adding and subtracting of radicals. When we add and subtract radicals, it's like adding and subtracting of variables. You can only add or subtract what we call like terms, or in terms of radicals, like radicals. In other words, if I were to give you something like this, where I have the square root of 3 plus the square root of 4, well, let's do the square root of 4. Let's do square root of 5. These are 2 irrational numbers because this is not a perfect square and this is not a perfect square. You can't add them. They're not like radicals. You can't say this is the square root of 8. It doesn't work that way. And you can try it on your calculators and you'll see it doesn't work, because if you took the square root of 3 in decimals and the square root of 8 in decimals and the square root of 5 in decimals, it would not give you the square root of 8, the same answer. So these are not like radicals. So what are like radicals? If I have something like 3 radical 7 plus 12 radical 7, these are like radicals because what's inside the radical is identical. And it's just like adding a 3x plus a 12x. The rule is just add the coefficients, 3 and 12, and you get 15. So your answer becomes 15 radical 7. So when you want to add, and of course, when you want to subtract radicals, you have to have the radical part, what's inside the square root has to be exactly the same for both. And then you just work with the coefficients, the numbers on the outside. So what happens if you have something that looks like this? Two radical 75. I'm taking this off the sheet that I sent you. Minus radical 48 plus radical 12. And I say, I want you to combine these radicals. Obviously, it's not just adding, there's some adding and there's some subtracting. And when I look at it initially, my answer is can't be done. What's inside the radicals is different on each case. But what I'm going to try and do is simplify each radical. And after I simplify it, it might turn out that some of them are like terms. So how do we do this? Well, let's look at the 75. What numbers multiply to 75? One of them being a perfect square. I think everybody will agree that it is a 25 and a 3. I'm just looking at the radical 75 first. And the radical 25, square root of 25 is 5. So the square root of 75 could be broken down into 5 radical 3. But notice there was this 2 here originally. Now the basic rule is if you have a number in front of a radical and a number inside a radical, you cannot multiply them. You cannot multiply something outside a radical with something inside. But if you notice the way I simplify it, I've now taken this 5 outside of the radical. I changed the square root of 25 to 5. So now this 5 is no longer inside the radical, and I still have this 2 here from before. Now I can multiply this 2 times this 5. So this gives me 10 radical 3. In simplified form, 2 radical 75 is 10 radical 3. So what do? We simplify the radical and then multiply the old number outside with the new number outside, and that's what we got, 10 radical 3. Okay, now let's go to this 48. Remember, we did 48 before. We broke it up into 16 and 3. And the radical 16 is 4. So this becomes 4 radical 3. There's no number or only a 1 outside. So this becomes minus 4 radical 3 for the radical 48. And now we have radical 12. Well, 12 can be broken up into a perfect square, which is 4 times 3. So this is the square root of 4 times the square root of 3. And the square root of 4 is 2. So this becomes 2 radical 3. Again, there's only a 1 on the outside. So this just becomes nothing to multiply by, 2 radical 3. So we started out with this expression that had nothing, no simple, no like terms, no like radicals. And after I simplified everything, the numbers inside the radicals all turned out to be the same. So when I want to add them, I just work with the coefficients. The 10 and minus 4 is 6. 6 plus 2 is 8. My answer becomes 8 radical 3. So it's very important to know how to simplify radicals, because once you simplify radicals, you might be able to combine terms that didn't seem to be like terms or like radicals. Let me see. I'll give you one to try on your own. Okay, here's one for you to try. Okay, we have 4 radical 8 minus 2 radical 50 minus 5 radical 72. A simple 72, not 32. Let's see if you can simplify the radicals and combine any like radicals. They not always turn out to be like radicals, but you have to try. Okay, let's do this together. First, the 8. Obviously, I'm going to break 8 into 4 and 2, because 4 is a perfect square. And the square root of 4 is 2. I have to now take this 2 and multiply by the 4 that was on the outside originally, and that gives me 8 radical 2. That's a simplification of 4 radical 8. Now I take the square root of 50 and I break it up into 25 and 2, because that's a perfect square, 25. The square root of 25 is 5. I'm now going to multiply it by this 2 here, so 2 times 5 is 10. So this becomes minus 10 radical 2. And finally, 72. If you divide 72 by 2, you get 36, which is a perfect square. So this is going to become the square root of 36 and the square root of 2. And the square root of 36 is 6. I now have to multiply the 6 by this 5 here. So this becomes minus 30 radical 2. And again, what looked like something that could not be combined is now all like radicals. I just work with the numbers in front. 8 and negative 10 is negative 2. Negative 2 and negative 30 is negative 32. So my final answer is negative 32 radical 2. Or this is, remember, these two are being multiplied. So that's why it is so important for us to be able to simplify radicals, because by the rules of addition and subtraction, we must have like radicals. So let's just touch on what do we do then when we want to multiply radicals. We're going to talk about multiplication, and then we'll go on with this on and division next time. But let's just talk about the rules for multiplying radicals. Remember, our rules for adding and subtracting was only like radicals. But when it comes to multiplying, let's say I have 3 radical 7 times 2 radical 14. Suppose I have 2 radicals, 3 radical 7 and 2 radical 14. Can we multiply them? Well, first of all, they both have to be square roots. You can't have a square root with a cube root. They both have to have the same index. But if they do, then the method is quite simple. What you do is you multiply the coefficients, the numbers on the outside, together. So 3 times 2 is 6. That gives me 6. And then you multiply the numbers inside the radicals together. And 7 times 14, let me get my calculator. I think it's 98, but let's just make sure. 7 times 14 is 98. Never multiply a number outside a radical with a number that's inside radicals. Outside numbers can get multiplied together. Inside numbers can be multiplied together. Of course, after you've done that, you should try and simplify your radical. And if you look at it, if you divide 98 by 2, you get 49, which is a perfect square. So it's 49 times 2. And the square root of 49, of course, is 7. So now I multiply the 6 times the 7, and that gives me 42 radical 2 as the answer for multiplying these two radicals. So the rules for multiplication are pretty direct also. Let me just give you one to try, and then we'll end class. And we'll continue with multiplication on Thursday. So let's say I gave you this. 3 radical 5x² times 12 radical 15 x 7. See if you can multiply this and then simplify. Craig, please look, I sent you a text, the chat. Craig Ricketts. Okay, let's do this. So first step, when we want to multiply, we want to multiply any numbers and variables outside together. And then we want to multiply what's inside the radicals together. So multiplying the numbers outside, we get 3 times 12, which gives me 36. And inside the radicals, we have a 5 times a 15, which is 75. And the x fifth times the x seventh, remember when you're multiplying variables, you add their exponent, gives me x to the 12th. Now, you might say, oh, this 36 is a perfect square, but it doesn't bother us whether it's a perfect square or not, because it's not inside the radical. I don't have to take it outside the radical. Anything that's outside is already simplified. Don't touch it. Just work with what's inside the radical. So here we're going to break this into our 2 square roots. 75, I think, 25 times 3 is a perfect suggestion because 25 is a perfect square. The x12, oh, that's a perfect square also because it has an even exponent. I don't have to split it up. I leave it as x12 in the front. And now I take the square root of 25x to the 12th. That'll give me 5x6 times radical 3. But now I have to take the 36 and multiply it by the 5. Now, you could probably do it in your head, but let's do 36 times 5. These are both outside radicals, so they can be multiplied together. That gives me 180 x6 outside the radical times radical 3. That's the answer I got by multiplying these 2 radicals. And again, notice I multiplied what was outside the radical, then I multiplied what was inside the radicals, and then I simplified the radicals to get what the smallest number inside the radical that I possibly can. Okay, we're going to stop right here. Oh, okay, Ashley, good. I'll take it. I see you're here. And we will continue with our discussion of radicals on Thursday. Don't forget to look for homework on Delta Math. If anything, if you are about behind on your Delta math. It definitely is going to affect your mark. If you're looking at your marks that I sent you and you're asking me, oh, I thought I had a higher average, probably the reason is because you haven't completed all your homeworks. So make sure you complete all your homeworks. If you're missing any tests, make sure you're completing them as well. I will see you on Thursday. Have a good day. Thank you.
Have a good day.
You too.
Pardon me,
Bye,
Professor.
Craig, email me when you are going to be available, at what time, so then I can set it up for you.
Excuse me, Professor. I have a question.
You want to take it now? Oh, well, yes. Who's asking me a question?
Angelica, I have a question. When you sent out the current grades, did you send it on like email, like on Outlook, or is it on Blackboard?
I sent it out from Blackboard as an email. It went to your, whatever email you have listed with Blackboard, the same email that I send out notifications all the time. If you didn't get it, email me and I'll send, and you want it sent to a different email address, I can do that. Just email my.
All right, thank you. I'll check it out now.
Just take a look, because it is, what I do is I just, those are the emails that I have, are the ones listed on Blackboard. But I sent each person an individual email.
Okay.
It took me a couple of hours, but I felt that that was the best way to do it, to get in touch with everybody.
All right, I'll check it out and I'll email you if I can't find it. Thank you.
Okay, great. You're a good student. Great. Thank you.
Have a good day.
You too. Bye-bye.